Dobrodošli na DESCON 6 online od 27. do 31. oktobra.
So let's start. Well, this year we actually need to do it online like this. Usually it's like in person, so we have much more interaction with the audience in our crypto parties, and we get questions and we answer them straightforward as they are asked. But today it will be a little bit different format. We'll try this out. So I'll go with the presentation, and at the end you can ask any questions, of course, in chat, or you can unmute yourself. So, okay, we can start.
Okay, so I hope you hear me better now, and we will start with the presentation. Okay, so as I said, this is the 6th time already that we are in collaboration with the DESCON and the DES, organizing these crypto parties, and usually they were in person. So we would immediately answer any questions that audience has, or any issues or problems, or whatever the interest of them were, and why they joined, and to be at the crypto party. So this time, unfortunately, it will be different. So I will go with the presentation, and at the end, audience can ask any questions or ask me. I'll also stay on the big blue button, and or on the IRC network also. We have a room, DESCON, for issues, but we can also use it for the questions. So I'll stand as long as needed to satisfy all the questions and answer them. So who are we? We're CryptoParty Serbia, and we all actually started here in Hackla Belgrade, Hackspace Belgrade, in about I think it was the summer of 2015 that we actually established the ideas of what we want to do, and everything, like how we're gonna go forward with this. So it was here that Hack Lab provided everything for us that we wanted to do, and people joined here with the similar ideas, joined the community. So it is the same ideas that global international crypto parties are actually all about. It is about open source software, it is about freedom of use, and protecting the privacy and the security and anonymity, if they want, of the end users. So using those open source tools. So this is like the global overview. Of course, ISOC helped us a couple of times. We traveled with them and organized crypto parties, not just around Europe, but around the world. So it was actually pretty fun and nice experience. And as I said, this is like for protecting privacy, security, and anonymity. Also, we fight censorship, and cryptography is very useful in this sense and can actually help it. And we will see about some projects that help bypass censorship a little bit later. And also hacktivism. Hacktivism is one of the main drives, I would say, in the communities similar to the Hack Lab. So using open source software, coding, and using stuff that it's not supposed to be used in some innovative ways to help users. Also, we are all free, liber, open source software fans, and it is now, I think, we are in parallel with this PSAs, or as it old age, PSOH conference that is also about open source hardware and software at the university in Belgrade. So that's also nice. And of course, freedom. Freedom is what the users can actually get by using this software that protect their privacy. Freedom of expression, of course. Okay, what are we going to talk about today. This will be like some kind of overview. So I think this is more or less the same as agenda, maybe some little bit modified, but generally is the same thing. So we will be talking about encryption, how it works. Of course, email encryption is the most popular way of using it and actually seeing in practice. Second thing is, of course, internet access. People want to access some maybe confidential information, something that they don't want to be public for everyone, for their country, for their city, internet service providers. So there are networks that use some open source software in achieving that goals. It will be protocols and application for encrypted messaging, so not just email, but messaging, protecting web browsing searches, so protecting the programs that actually go to the web and do anything for you that you want them. So protecting those programs that are most vulnerable and used every day by the users. And the bonus section will be about social networks today, because there is a lot of maybe censorship lastly on them, and what we can do as users to kind of overcome these problems. And the main problem is that they're centralized and not open source, actually, many of them. Of course, we will talk about most important stuff. It's passwords, because this is the field that most users fail, and most breaches happen because of the weak passwords or reused passwords or poorly stored passwords. Passwords are just the biggest headaches for everybody, actually. And lastly, about security of the operating system itself. What can we do to harden our operating system to be better protected against attacks? And a little bit about physical security of the devices that we carry with us and connect to the public networks, Wi-Fi. Okay, so how the encryption works. This is the oldest known encryption method. It's called symmetric key encryption, and it actually uses the same key for encryption and decryption, and both users that want to exchange secret messages need to use the same key. So even if the encoded messages or encrypted messages will be transported over the public internet, that won't be the problem, because they will be encrypted. But the main problem would be that the key needs to be shared some way, but we cannot share it over the open internet. So both parties need to somehow agree on that same key off the internet, in person, or try to find some other way to securely exchange the same private secret key. So this is the main problem when it comes to communication, and this is the part where next section goes in and says asymmetric encryption. So this is actually the fairly new invention, I would say, in 80s and 90s, last century. This has made actually internet possible today, because it enables two parties to agree, not just agree, but exchange messages without exchanging the private keys. So it actually uses, this kind of encryption uses two keys, private and public, that are related one to another. Each party would generate on their device, on their end, both keys, and they will just exchange the public keys to one another. So no private information there, so nothing to worry about. But using those public keys, each of the parties can use those public keys to encrypt the information for the other party. So in this case, Alice would be using Bob's public key to encrypt her message, and then send the encrypted message to the Bob. And in this scenario, we will see that over the internet, only public information goes in. So public key and encrypted text, so nothing to see. Actually, third party cannot decipher this or see what's the conversation about. And Bob will use his private key that corresponds to his public key and decrypt the message and see itself what's in the message. There are many applications of this technology today. So other than encryption and decryption, as we saw in this diagram, the public key encryption is today used for actually signing documents or software and verifying the signature. Aside from that, the asymmetric encryption can be used for key exchange. What that means that we can actually use this public and private keys in some kind of message exchange or protocol to agree on the one shared symmetric key. So we will use this asymmetric encryption schemes to agree on symmetric key. Why is this actually useful? Because as we know, asymmetric encryption is far slower than symmetric. Also, today's processors are also built with this algorithms for symmetric key encryption. So it will be normal to use symmetric key cryptography to decrypt the stuff. And to do that, we'll need to agree on some keys in advance, then use symmetric key encryption to faster encrypt and decrypt stuff between two parties. Today, this is used in HTTPS, so SSL, secure socket layer. Many stuff today depends on this technology, like bank transactions, virtual private networks, secure shell, so accessing securely some computers remotely, instant messaging, as we will see shortly. Newest ones like cryptocurrencies and the software signing. Software signing, this is actually something that most of you who use any kind of software actually probably came across every day, but you're not aware because big companies like, for example, Microsoft, Google, Apple, all of them sign their software with their private keys. So when this software is downloaded to your computer recognizes the signature and verifies that the software actually came from this provider and not some malicious third party or some attacker or something like that. So this is actually very useful for fighting the virus spread or malicious software on the internet. And for applications, we can use asymmetric encryption to post messages of social networks. This is not that popular, but actually can be utilized. So the other users can actually verify that it is actually me who did it, because when you register on some account on forums or social networks or stuff like that, what you actually don't know that is that the administrators of this company controls your account. So they can delete it when they want, they can change your password without knowing, especially in earlier days. Platform owners do have ownership of your account. So if something is happening and they want to like abuse this power that they have over accounts on their platform, they can actually do it. And in order to prevent this and make sure that that other users who are listening to you on those platforms can make sure that the information that you are posting is actually from you and not the administrators of those platforms, what you can do is sign all of those messages. So they will not be encrypted, just signed, and the administrators cannot do anything about it. They can delete them, but they cannot modify the signature or sign them themselves or impersonate you. That wouldn't be possible. Interestingly enough, math behind this asymmetric key encryption is fairly easy to understand. This is like middle school mathematics. Multiplying, powering of numbers, modular arithmetic, and division by reminder, or also known clock arithmetic. So it is easy to understand, and we actually explain this in our crypto parties when we do physical part of this, like in real world. But I don't want to bother you with this math stuff now. So one of the areas this is used, and in early days of discovery of this, is actually mail, because mail was back in the 90s much more popular as for information sharing, and the open source implementation of the known protocol that uses asymmetric encryption is also known as GNU Privacy Guard. This is independent of the underlying protocols. So you can use, as I mentioned, for posting on forums, for emails, for whatever you want. So this email encryption protocol is independent of the platform that you want to use it on. So this is actually cool because you can implement it on whichever platform you want. You can tomorrow invent some new, I don't know, social network and implement, and all the users will be able to use GPG with their keys on your platform to securely exchange encrypted or signed messages. So this is actually great to have it independently, independent protocol. And email providers do not have access to GPG encrypted messages, of course. So I think there is another slide of this. Yep. So what this means is actually if you are using GPG or some other kind or implementation of asymmetric key encryption, nobody between you and the correspondent cannot actually see the content of the message. So this means that your internet service provider or email provider of your choice or the choice of your correspondent, they can see only that you are exchanging encrypted messages. They can see some kind of metadata like who you are, your email account, and when you are talking to someone and stuff like that. But they cannot see, and who is that someone, but they cannot see the content of those encrypted messages. So this is actually very good. So the downside of this is actually that everybody who wants to participate in this encrypted information sharing over email needs to have their own key pair. So this means that if I want to talk to someone, that someone also needs to know at least something about this and have their own keys. And if I want to send them an encrypted message, I need to get somehow to their public key and then use this public key to encrypt and then send a message. So this means that everyone needs to do some part on their end to be able to securely participate in this encrypted communication. And another thing that this is useful for is this key signing. So in our crypto parties, the second main reason I would say that people gather on one place is to actually verify and sign each other keys. So this means that when you come to some kind of crypto party and you exchange these keys and you verify that this person that you are sitting with actually is the owner of the private part of the key, and then he actually has it. So there is no impersonation, because this is not some social network platform where they verify your email or SMS number, phone number, or whatever. There is no any kind of identity attached to it. You can lie about your email address. You can lie about any information while creating a key. There is no checking on it. So the crypto parties are there to actually make users come to each other and verify each other's identities. And also key servers are used for publishing of those keys to be easier for participants to exchange public keys to each other. And if someone wants to contact you, you will have to upload the key to the key server, and then the other person, when he or she wants to find this key, it will go to some of the key servers and just look up your email, and this key server will output your public key. So yeah, this is the simple scheme of this. Two users encrypting messages. So Anna is using some kind of text and the public key of the Boban, and encrypts the message, sends it to the internet. That internet sends to Gmail server, because Anna uses Gmail, of course, and then the Gmail transfer this also over the internet to the email server of the Boban, and then that server transfers this to the Boban. And the important thing here is to see that nobody on the internet or the server providers of both parties are able to see the content of the message. They can see the communication is happening and they're sending some encrypted stuff, but nobody can decrypt it. So all decryption is done only at the ends. So this kind of encryption is also known as end-to-end encryption. And GPG or email encryption is one of the ways to do it. So, and this is how it looks like, actually. So when you receive a message, you'll receive it like this, and this is the format that also the internet service provider will see it in. And only if you locked your key with the password, you will be prompted, of course, to enter the password to unlock the private key and then decrypt the message. If you didn't lock it with the password, this is like some kind of extra protection for your private part of the key. If you didn't lock it with the password, this is also fine if you trust your device and don't transfer this private key over internet or USBs, stuff like that. So in many cases, if you want to transfer this key, you will want to protect it with additional password. But if you don't, then the email client manager will recognize the encrypted message and try to decrypt it with your private part of the key, and you will see the message, the actual message content unencrypted later. So how can you use this stuff? So for Linux, and I think for all the desktop environments, there is a Thunderbird email client, popular choice, open source, of course. This is from Mozilla Foundation, and it goes with Enigmail. This is a extension for managing encryption, decryption, key management, signing, verification of signatures, key creation, stuff like that. So this was like this for a long time, maybe more than 10 years. But I know that in next release of the Thunderbird, the Enigmail will be included inside, so you won't be needing to actually install any additional stuff except for the email client itself. It will be everything included inside of this. So it will be like much more easier, or like one step easier. And if you have some other operating systems like Windows, then there is a GPG for Win software. You have links here, and we will publish the presentation, so you will be able to go and click on those links. And for Macintosh, you have GPG tools. All of those are also open source. So there are other software that are not open source for use of email encryption, but I will be presenting here only open source solutions. So those solutions can integrate with the other non-open source email clients. I'm not sure what you're using on Mac, but on Windows, whatever you're using, the GPG for Win can integrate with. For email, there is a new email client and key manager called PEP. So this is Pretty Easy Privacy, short for Pretty Easy Privacy. And it actually automates most of the stuff that earlier solutions did. For example, we for a long time used K9 mail for Android. This is email client, and then on top of that, we needed to install Open Keychain. So this is for key management, same as for Thunderbird and Animail. So this was like just Android versions of those two. And now we have this pretty easy privacy client that does everything by itself. So by some means, the email encryption on Android is a little bit easier now, and can maybe see wider adoption. We also have some tutorials in Serbian language that we made for crypto parties that we organized here. So if you want, you can see them on our website. And for the key servers, that there were, I think, last year or the year before, there were some major issues and vulnerabilities disclosed about traditional GPG key server. And there is a new type of key server, and then probably everyone should be switching to if they plan to use this email encryption and post and download keys from those key servers. So I'm not sure if the Enigmail and Open Keychain and software like that replace the key server, default key servers in their software, but just in case, the servers that use some kind of different protocol are now more safer and can be found in this link. Next one is for the messaging. So this is the first and simplest protocol, security protocol, to use with asymmetric key encryption to secure instant messaging. It is somewhat better than the GPG because it has some cool features like deniable authentication and forward secrecy. First of all, this forward secrecy is maybe the most important because it guarantees that no matter what kind of key exposure you had, like maybe someone stole some of your private keys, or you lost them and now you're afraid what will happen to your messages, past messages, will someone be able to decrypt them now? So this is solved with your off-the-record encryption with this forward secrecy that actually guarantees that once the keys are exchanged and messages should be encrypted, each message will be encrypted with a new temporary generated key. So if you lose some of the keys, that will not mean anything for you, because at the most, attacker will be able to decrypt one of your messages. So in the case of GPG, if you lose your private key and attacker has access to your past emails that you sent or received, he can actually decrypt all of them. So this is the problem, and this is why the guarding of the GPG private keys is very important and maybe even hard to do. But with the OTR, this is also solved. Mutual authentication means that when two users want to chat over the internet, there is a possibility that maybe server owner or someone in between can impersonate user A to user B and user B to user A. So he can actually say to user A, I'm user B, and to user B, I'm user A. So user will be thinking that they are talking to each other, but they will be talking to the same malicious actor in between. And to overcome this problem, OTR uses the, mutual authentication. This means that at the end of the protocol, both parties will have some kind of short, how do I say, it is not secret, but the short verification letters or string that they can actually compare with each other. So if this string is the same at the both ends, then they successfully established secure channel. If it is not, then both parties know that someone interfered with their secure channel. And the good part is that that third party that wants to interfere and hack their secure communication cannot do anything about this. So it is very hard for it to generate for both parties that it wants to impersonate the same output keys, because the protocols will be the different. Every time you want to establish secure protocol and start doing it, it will start from new random numbers and stuff like that. So this is actually good, but the main downside of this protocol is that it is only designed to be used between two parties. So if you have a group of 3 people or more, you cannot use this protocol. This is not feasible to do it in this way, because it is not guaranteeing anything for the third party. So only 2 parties can use this protocol. But this is older protocol, and it was older, maybe 8 years till 2012 or 13. Then we developed another one. It's called OMEMO. First, it was called multi-party OTR, but it was very shortly renamed to OMEMO. It has the same features as the OTR, but it can be used across more than 2 users. So this is the same, maybe not the same, but very similar protocol to what we now use in Telegram, instant messaging, or Wire, if you know about this, or Signal, stuff like that. Protocol is open source, so others can see how it is implementing, what it's doing, and it is worked on. It is one that is actually developed. The company and the people who did the most for this were the guys behind Signal protocol and Signal application, and they modified the same protocol and called it Signal. But more or less, this is what it is. And other companies also did the same. Some of them modified but didn't disclose the new modified protocol. Some of them did, and it will be on you to decide what would you want to use. But we'll also always ask people, if they want security, better to use something that is open. This protocol also implemented some good features, so to say, some useful stuff, because this protocol treats every device like it's another user. So it doesn't mean if you have 2 or 3 devices that you want to communicate from to other users. For each device will on its own and create their own pair of keys, and the software, the protocol, will treat all the devices as different users. So it doesn't matter if there's 2, 20, 200 users, or how much you use, how many devices you're using. Every device will have its own key on itself, and it will, when the encryption comes in, the software will encrypt for each device that is in the room or in the chat. And it has offline synchronization, of course, and supports file uploads. And yeah, so if you can host your own server, and as we do here in HackLab, but we paused it now during the conference. It was very loud here. So we actually started our own XMPP server and implemented this OMEMO, but this OMEMO is also implemented on the client side. So we just had to enable some stuff in configuration, and everything is done on the client software, on their machines. So this is very, very easy, both for us as administrators of the server, and both for clients, because they don't need to do anything. They just install the correct applications, and everything is done in background for them. They just need to verify the keys. That's the only part that they are left with. And this is also the scheme of the protocol. So it is very similar to the OTR, but we now have more parties. So the interesting part in encryption scheme of this is that we are using the same symmetric keys for everyone. So we told earlier when we learned that symmetric key encryption is much faster than asymmetric, so it is utilized as much as possible with when we don't need when there is no compromise to the security. So in this protocol, when all parties exchange their keys, then all of them agree using the Diffie-Hellman key exchange, one of the most popular key exchange protocols based on asymmetric key encryption, to agree on the same secret symmetric key. And then we use this secret symmetric key that we all securely agree on to encrypt the messages. And how all the parties decrypt the messages, because this key can be onward changed using some algorithm that all the parties know, and everyone knows, but they don't know the starting private key based on which the new keys will be generated. So each time the new message is sent from one user to all the rest, it encrypts the message with this symmetric key, and then encrypt the symmetric key with asymmetric key, and this is stored in the header of the message. So when the message is actually encrypted sent, it has two encrypted parts. One is with symmetric key encryption, and one is asymmetric key encryption. When any party receives their message, it will decrypt the header and get the key from the decrypted header, and then decrypt the message with that key. So what this means that the sender actually needs to encrypt n-1, or for all the other users except from himself, the messages, and each of the message will be the same. So the main message encrypted will be the same, but he needs to, or she needs to, encrypt the header for each of one of the other participants independently and add it to the message, and then send those number of encrypted messages to the network. So it needs to encrypt it specifically for Marco and set the header with the same encrypted message for him, as well as for Boban. So this is actually the hard part for the bandwidth maybe, but this is how it does. So OTR and OMEMO clients, I tried most of them, and now I'm with Dino. And Dino is not maybe the best, but it has most nice user interface and will be very easy for new users to use maybe Dino. Dino is for, I think, Linux, of course, but I'm not sure, maybe for Windows also. Adium is for Macintosh users. C, I think, for all platforms. Koi, internet messages in IAM is for Windows and Linux, I think. Pidgin, Windows and Linux, and Gaim, I would say Linux, maybe Windows, not sure. And you can actually see the pattern. There is not so many clients for Mac users, for Apple users, but yeah, I'm sorry. This is the sad part. But Android has a bunch of them, and there is this pretty easy privacy again. Zom is maybe not that known, but ChatSecure is once very, very popular. Xaber is one of the stuck for a few years now. And Conversation is maybe the most popular because it is very easy to use, similar to other ordinary chat, internet chat software. So, and I didn't have much problems with it. I'm using it on my Android device, so this is like the best maybe for Android. You have the links for everything that I talk about this instant messaging encryption, and we now need to mention, of course, the big players in this field. So there is Telegram. We used Wire, and we are still using it for our own internal communication and Hack Club and with the other people that we meet on our crypto parties. and it was somewhat good and nice. Some people experienced some issues with it, and maybe didn't see some messages or stuff like that. But I think that was like less than 10% of the people. Mostly, it was very nice to use. Signal also. Signal is, I think, one of the most popular for secure encryption. It has many good features like disappearing messages and stuff like that. You can back up your conversation and keys. And, that's very useful. And I'm not mentioning any closed source software here. So Telegram is partially closed, but it is very popular in the community and considered to be secure so far. There is an interesting site, Electronic Frontier Foundation has about secure messaging. So they compared maybe 20, 30 or something like that of messages, both open and not open source, and with the features that they have, so you can see how each of the messaging applications score in this this page, and that's very good. There are many features that they didn't cover, but there are like 6 or 7 features that they felt that are the most important, so they put them in this in their website. And the criteria for the secure messaging is that it will be very useful if they are not centralized. So what happened a year ago, it was that at the same time, both Signal and Telegram weren't working on a couple of continents, actually. So that was the problem for the users, and this is what I wanted to emphasize now, because many activists use this centralized software and they heavily rely on them. So it will be of great advantage for them to use something, not just something, not something else, but something to complement this this application. So it is fine that you use, and we also use Wire, and that's fine. But if their servers go down, we would like to have some kind of backup solution to continue the communication. This is also for all the activists who are on the street and want to communicate. Maybe police can come and cut the 3G, 4G, or whatever internet, so they won't be able to communicate. Or so it is important to have some kind of alternatives and backup plans if your main secure application for instant messaging fails to use something else. There is one called Briar messaging. I forgot to include it in the presentation, but you can easily find it on internet. It has also features for offline communication, so you can communicate over Bluetooth if the internet is cut. So this is like the good alternative to have, not just alternative, but to have it besides this most popular application, just in case. Because one of the main issues is when your main application for instant messaging is not working, you will need to authenticate the other users again. And if you're far away from them, it can be a problem. So when you're gathering on the CryptoParties, try to do this verification for other applications and platforms also. So when you come to CryptoParty, don't just bring your one application for verification with others and application. Bring at least 2. So bring Signal and bring Wire, or bring XMPP, Jabber message and Wire or Signal. Bring a couple of them. That will be of great advantage for you in these critical moments if they occur later. So Tor, now we moved for internet securing internet connection and browsing. So Tor is the project, open source project. It is developed by the US actually, and they are military. But it is open source, and now everybody can review the software and how it's used and how it's working. So it is a network that consists of volunteers. So everybody, we are actually running, I think, some nodes, and I know many people that are running the nodes at their homes, and this is all fine. There helping the network be bigger, and if the network is bigger, then the more users are anonymous and harder to identify. So I think it currently has like 6,000 or something like that nodes in, and maybe in millions of users of this network. So the network always needs more volunteers that will run this software at their end. So the way Tor communication works, or protocol, is that it encrypts all the traffic that is coming from the client with a 3-layer encryption. And then we have a graphic that we will explain. And then all the encryption remains in the network as packet pass, and it is decrypted by the nodes as it passes from one to another, or from one to the next one, until it reaches the last one, and then it is forwarded to the internet itself. So it hides the user from the internet and hides his identity. It is mostly used for people to anonymously surf or bypass censorship in countries in Middle East and Asia. I didn't want to name any of them right here, but I think you all know who I'm talking about. So, and those countries actually use some kind of protection or fight against this software, but the Tor project also has their own other additional projects and software that try to also fight this censorship stuff from the countries. So this is an ongoing cat and mouse game all the time. It is very easy to use it. You just download their bundle, Tor browser bundle it's called. So you can use it on if you're on the desktop, you download this bundle. If you're on the Android or Mac or Apple, so if you're on the phone, they have their own I don't know how it's called, applications. So it is easy to find it on their website or on the App Store. You can easily find it. So this is the graphic how it works. At the left part we have user, and this user using their Tor project software this software has all the public keys of each node in this in the Tor network, and the user randomly chooses 3 of them. So there are 6,000. This software has public keys of 6,000 computers that are in the network, and it randomly chooses 3. When it randomly chooses 3, it starts encrypting the message or the packets for each one of them. And the way it works, it encrypts the packets for the last one, and then this is the last one is this exit node, then for the middle, and then the third layer of decryption is for the starting entry node or the guard node, that is the first in this sequence of the 3. And when these 3-layered encrypted packets are sent to the first one decrypts its own, see where this should be forwarded to, forward to the next encrypts for his part, for his layer, then forward to the last one, exit decrypts his part, and forwards the traffic to the internet or the internal network of the Tor that is also accessible now that you have this software. So, and then the process goes the same in the back. So what this means, why 3 not 4 or why 3 not 2, this means that if you're using 3 of them, none of them know all the necessary information to identify you. So for example, the first node or the guard node knows who you are, but doesn't know what you are trying to reach from the network, what would be the destination of your search. And he just forwards the traffic to the second, and that's everything he sees. He sees you and the second node. Second node doesn't know anything, doesn't know who you are or what you're trying to reach. The second node or relay node knows only the first and the exit node, and it forwards the traffic between them. And the third node doesn't know who you are, but knows that someone from the internet is trying to reach. Someone from the Tor is trying to reach something on the internet or Tor internal network. So it does it for you like a regular proxy, and then returns the results to the relay node, and that's it. So none of them know who you are and what you're trying to do. Some of them know some parts of this information, but none of them all. So this is why the Tor project is considered to be anonymous. Of course, if one of the nodes is compromised, say whatever you want node to use, for example, the guard node or the relay or the exit, if you choose one and say, okay, this node is compromised, I know that the malicious actors are using this as a honeypot or something like this to catch users, that will not do much damage to the user because one of them knows all the information. So they may be able to know that you are using Tor or that someone is actually doing something, but they still won't have all the information. On the other hand, if two nodes are compromised, that will be like for serious. But this is why the network needs to be bigger. So the bigger the network is, the less the probability is that one or more nodes are compromised. And because everyone can run the node, you actually don't trust anyone in the network. So this is why it is anonymous by design. So yeah, we also talked about this types of nodes, relay, guards, and exit. And there are directory authorities. So not to go deeper in this, but the directory authorities, they're just the special type of node that Tor project and the people in the Tor project choose. And there are like 9 of them, I think, or 10, that are the special trusted people who operate these special directory authorities. And they kind of vote on who are relays, who are guards, who are exit, if they're trusted, if they're not, and what's the time in the network and stuff like that. So they're trusted part, and this is the bad part from my side and my point of view, because this makes them kind of centralized in some part, but not completely. I think the Tor can be also made to work efficiently without them. Yeah, so we talked about the censorship and the stuff that the Middle Eastern and some Asian countries are doing to prevent the use of this software on their networks, so to prevent the spread of some information from other countries to their citizens, stuff like that. And the Tor project was countering their counter actions against the Tor with pluggable transports, and they have a few of them that actually work. I think now all of them can bypass the deep packet inspection and different kinds of things that those countries do to identify Tor users and try to block them. So you can see this link. I wouldn't go deeper in this, but yeah, this is like, if you're having trouble accessing the Tor or the internet using the Tor project software, you can always use this some of the pluggable transports and request some non-listed secret Tor nodes to be emailed to you or sent some way, so you can use them to bypass the censorship. And it is not that hard to use. You have they made a pretty easy, straightforward GUI in their software. So you just click next and just read what it says, and you'll get the special secret Tor nodes to access the internet. Okay, so that was Tor, and I expect some questions on that. But okay, now we can shift to another thing. This is a VPN, and it has become most popular and ever increasing market ever since the Snowden disclosed his revelation about the spying of the American CIA and NSA, mass spying on emails and internet traffic and all what they can get. They were not collecting just metadata as they said, but they collected everything they could. And did some nasty stuff on the internet too. Tried to, I think the one project was called Quantum Insert that tried to manipulate the traffic and route the traffic to them faster than the other nodes on the internet, crucial nodes, crucial servers, to try to trick them. So VPN became ever more popular for users who maybe want to access some internet that is access some content that is restricted or maybe only available in some countries. So if you want to access something that is only available in the UK, some stream or some game or whatever, some website, and you can do it from your country, then you will use the VPN that has servers in that country and then securely access it. So, but the main thing to emphasize here is that the VPNs are not made for this purpose. VPNs were made for the companies, for their employees to securely access their company networks from home, from travel or whatever. So to appear like as they are in their network. And companies try to make their network secure, and then VPN is just a way to like virtually transfer them into their secure office networks from wherever they are in. And this is the main reason why the use of the VPN today is not how would I say, it is not the purpose that it is made for, but they're using it. And from that information, many people have also maybe wrong ideas about what VPN is, because it isn't designed to make you anonymous or not seen on the internet or something like that. And the companies actually want to sell their software or their service to you by saying this. They're secure, that if you use their servers, then you're anonymous, then nobody can track you. And there were many scandals with many private companies that say that, tricked the people using the software, that did some malicious stuff, and then law officers came to their companies and got all the information, all the metadata, and everything, all the logs, everything that they could collect to identify those persons. So VPNs fail multiple times in protecting their users, and not many users actually know that, and they are easily tricked by the companies trying to sell their product. So this is very important to understand for users if they want to do something online, that the VPN, and they're using VPN to do something, that VPN will always know who they are, where they're from, and what they're doing, because the VPNs only encrypt the traffic between the users and their servers. So maybe VPN companies will tell you that they don't keep logs or stuff like that. This is not possible actually to verify either by users or anybody else, because nobody knows what company is doing, that they can change it every minute, and there is no way that their users will be notified or they can audit what the company is doing. So security is there, so they have good security in some of the protocols, and there are many protocols for VPN, and I bolded here the ones that they are considered to be secure, and that the implementation is open source. So one of the most popular is OpenVPN. It is available on all the platforms. So whichever device you have, you can install the OpenVPN client and then find some servers and connect to it. L2TP IPsec is the other. It is popular. Some companies are using it. I had the pleasure to do it, but it is not that simple as OpenVPN, maybe. PPTP, SSTP, and SSL. PPTP and SSTP are proprietary Microsoft protocols and from other companies, and so we don't know what they are actually doing, how are they implemented and stuff, so we don't have source, so we cannot actually say this is secure or not. So there is a new one called WireGuard, and WireGuard is from year 2, open source. It was announced on FOSDEM. This is also open source conference, and I have been using it for some time now, both on my Android and on my Linux, and it is very easy to set up, I would say, and very easy to use. It can be used not just as the main routing source for your internet. So when you're using OpenVPN, for example, and you turn your VPN on, all your traffic goes through the VPN. With WireGuard, the situation is a little bit different. It established an encrypted channel with a VPN server, but it also leaves you a possibility if you want to route everything through it or just some part of the network. So it is easy to configure, and you can do a lot more than with OpenVPN, I would say. And IPsec and iKey version 2 are considered to be, I think, besides those open source, most secure, haven't been broken yet. They're out there from, I think, more than 10 years or more. So if you're using that, or if your provider, or if the provider of your choice is using that, it is also considered to be secure enough. And this is what VPN connection actually looks like. So you are encrypting traffic only through the to the VPN server. VPN server then sees everything: who you are, what you're trying to do, what you're trying to reach from the internet, and stuff like that. So yes, it can be useful if you're in some kind of if you're trying to avoid censorship or get around it. It can be very useful because the government and the internet service provider will see that you're using VPN server, you're connected to it, but they will not know what you're searching on, so they might let you do it. But on the other hand, it is very easy to identify if someone is observing what's happening on the internet, like your internet service provider. It is very easy to identify that you're using VPN. So when they look at the packets, they can see that you're a VPN user. So if they can easily identify it, then they can easily also block it. Okay, search engine and internet browsers. Search engine, there are a few alternatives. Like I probably have 20 of them, but I mentioned 3 most popular after Google. So they're DuckDuckGo, Startpage, and Qwant. I think Qwant is the newest one developed by the European Union. I think France and German, as they want to distance themselves more and more in the virtual world, not to be dependent on American companies. So if you're in stuff like that, then that would be the one for you. But there are also other alternatives, DuckDuckGo and Startpage. DuckDuckGo is independent, and it is providing you with the search results from their engine. I think everything is open source on their side. And the Startpage is just like an open source privacy proxy for the Google. So if you don't want to use Google, but you want Google results, like because they're the good quality and stuff like that. You don't want to use that information that you're getting from the Google when you search something, but you don't want to use their services because they are collecting information about you. Then you can use Startpage, and Startpage will, for any query, return you the what they queried from the Google. So they will do the stuff for you, not to expose you to them. And you can review the privacy policies and stuff like that also on their websites. The browsers that I use are those 3, and I use them both on my Linux and my Android. So Chromium is the good alternative to the Chrome. Chrome is not open source, but Chrome is based on Chromium. And if you're using Chrome, you can easily switch to Chromium on Brave or Brave. Brave is also based on Chromium. So if you have your bookmarks or extensions or whatever that you're using on the Chrome right now, you can easily switch to the Chromium or Brave, and most of the stuff will be, I cannot say 100%, but 99% will be compatible. I tested with some extension, I tested with my bookmarks, and everything worked like a charm. And the alternative to that is Firefox. Firefox works very nice to me. I use it in my work or for myself. Firefox is very good. We only had some problems now with with internet conferencing software for microphone and camera and stuff like that. It is not easy, good, very good optimized for those stuff, but for privacy and security, it is, I think, the best, because even the Tor project is using some version of Firefox that they stripped away of some things, and hardened privacy and security and stuff like that for the Firefox, and implemented the Firefox platform for their Tor browser. And there are links on this very cool website called Privacy Tools that you can also see more information about browsers and search engine recommendations. So I'll leave you to that there. And why not use Google Chrome or Google search engine? Well, they are global data aggregation in one place. So they trying to track you on a mobile device. They're trying to track you if you use their Google Maps. They're trying to track you on YouTube, on every platform and application that they have. So it will be very useful if you can like diversify some of the activities online that you do, not to give them all the information all about your internet activities to one company. So it will be better, like if one company is bad and you don't know what it is, well, use multiple of them. Don't put all your eggs in one basket. This is just like what you should have in mind. And browser extension. And this is very interesting part, because there are many, and I didn't want to mention like 20 here or 30. So I mentioned like 3, and you can go and try to find for yourself. I probably can guess that many of you are using like some dark backgrounds extensions and stuff like that. There is a website that you can go to check for, I think, only Google Chrome extensions if they are secure. I think it's called CRX Online or something like that, CRX extension checker. So this is online service that if you give them the name or the link to the Chrome extension, it can check for you what kind of privilege it will ask you or require you from your operating system or web browser in order to function. So you can easily review if you want to give this kind of permission to some extension or not, if that will be invasion of your privacy or not. And there is also a Privacy Tools IO link for the add-ons, mainly for Firefox, and they have good tutorial on how to harden all the settings in Firefox. And Firefox actually has some cool features. This is maybe from a year or two that I use frequently, and this is this container sandboxing. So you can reopen some types in separated containers or sandboxes, and those sandboxes will actually they'll provide you with this kind of protection that whatever happens in this sandbox will not affect other tabs or programs that you opened. Like if you opened multiple windows of your Firefox and you opened 20 tabs and you open something in a special container, like, let's say for work or for finance or for whatever they want, you can create your own. You can create your own sandbox, give it a name and stuff like that. You can manage it, and then anything that happens in this sandbox, if you, for example, have some cookies that collect information on you and stuff like that, those cookies will not have information and access to any other stuff outside of that sandboxed tab. So this is very, very useful if you want to like separate your banking from your finance, from your personal stuff and shopping and stuff like that. Are very advisable. Passwords. This is also the most important part, because even I sometimes lose passwords or make them insecure, and the best solution is always to use a password manager. So just to shift from one problem to another, now we need just to solve this by choosing the correct password manager. So also I'll advise the password managers that are open source. Some of them are there for your only use, like on your computer for your accounts that are not synchronized online and stuff like that. And I consider them more secure, and I use them, like KeePass or some other variations of KeePass. There are a couple of them, KeePass 6, KeePass 6C. And this is the one that I recommend because you can easily use this across operating system and platforms. So there is a KeePass for Windows, Linux, Mac OS, Android, you name it, there is a KeePass for that platform. So you can easily export your encrypted database of the passwords and import it on another device, or send it via email, whatever. Just make a good password for your main database that you keep other passwords in. And the second thing is very important, is two-factor authentication. This is to prevent hackers to access your account even if you made some mess with the password. So, for example, you use same passwords on multiple accounts, multiple platforms, and it leaks through your USB, or you tell it to someone, or somebody sneaks over your shoulder and catches this password, or some camera somewhere recorded your password. Now someone knows your password. In order to prevent hackers to immediately own your account that password that was compromised was for, that you can implement this two-factor authentication. Unfortunately, this is not up to you, but this is mainly up to the platforms that you are using. If they have this two-factor authentication enabled, then you can use it on their platform. If they're not, then you're stuck with only just a password for your account. But there is, I think, a website. You can also search it. Maybe I'll give you now wrong information, but there is a website that gathers the information of all the platforms that have two-factor authentication available if you want to enable on them. So you can search for that and see if there are platforms that you use and how can you enable two-factor authentication for those platforms. So this is for the offline passwords and passwords for you. But if you're in a team and you have like 20 people that you work for and need to share the passwords for the same account, you all use the same account for your activities, you want to promote something, your event or whatever, then you'll be needing something more, because sharing passwords in this one database that you have and then transferring that to other of your teammates wouldn't be that pleasant and easy to do. So there are alternatives. There are these password managers for teams, and I tried TeamPass and I tried Sona. I didn't try Bitwarden yet because it didn't show it didn't have for free some of the features that I wanted. So there is this alternative, or should I say fork, to the Bitwarden that actually doesn't have those restrictions that you need to buy your account if you want to use them. So you can self-host it, of course. This is all self-hostable. You can separate some kind of hardware, some PC, and install it on this. I think most of them can be installed even on the container like Docker, so you don't maybe need separate device. You can just virtualize everything if you want to just to test it. And some of the features for the team password manager that you want to look for is that if you can share the password with multiple accounts, if this solution stores previous passwords, there is now also options to check the hash of the passwords against websites that collect hacked or dumped database of the passwords and accounts. So like check if if you are reusing the password of someone else, if your password is good enough or secure. All those password managers have the feature to automatically generate the passwords for you, and this will be very, very advisable, because you don't need to remember those passwords. You just need to remember the password that you use for those password managers to access this database, and then just leave everything else to the password manager. There are also other closed source solutions that I worked with and that show to be very good, but I don't want to mention them because they're not open source again. And yes, one more thing, passwords and passphrases. I just forgot to tell you about that. If you're having trouble with passwords, you can also use this other technique called passphrases. So instead of using random characters, numbers, letters, and stuff like that, that is very hard to remember, especially if you need to remember something that has like 13 or 14 characters in. It will be very easy to remember just 5 words, like correct horse battery staple. This is from well-known XKCD website. So the main thing here is that main argument for passphrases is that it's easier for people to remember 4 words than random characters. And because we speak in our language with words, it will be easier for us to remember our passwords in the form of those passphrases, if we need to remember more than 1 or 2 or couple of them. So you can try this technique and see if you're going better with passphrases. And I think this will be almost the end. Yes, the operating system security. All that we talked about is very good and great, but the problem is that all this security depends on your device, because on your device, all of this encryption gets decrypted. All of the messages get decrypted so you can read it, and it is stored and in most cases decrypted on your device. So what happens when you lose your device? You need to think about this. What happens if you go to, I don't know, airport and someone tries, security guards ask you to inspect your PC, your hardware, or whatever? Will they be able to access your personal and private information? They won't if you don't give them passwords, and if they don't, if you use some of the encryption technologies for this, like full disk encryption. Most of the operating systems today support this full disk encryption, especially Linux. You have multiple solutions for this, but the main one is Lux. So you can encrypt your hard disks. You can encrypt your BIOS. This is also a very good thing to do, because if you lose your computer, nobody will be able to access this BIOS and change the stuff. There's maybe to get around the full disk encryption. So encrypt the BIOS, encrypt your disk, make good password for your user account on this operating system. So this is for the passwords. Then there is backups. You probably want to do regular backups of your important stuff, and you don't want to like keep the backups on the same partition or the same hard drive that you're keeping the originals one or the operating system is on. So you want to take it somewhere offline on some USB or external hard drive, or use some online cloud service to encrypt stuff before you upload it to the service. So there is also software for that if you want to do it like this. And I think yes, you can find the software for that also on the website Privacy Tools. Firewall is now, of course, one of the software that you want to have on your PC, especially if you are going on public networks, networks that you don't trust, and maybe the services on your computer are using the network and have you exposed through them to attackers, and you want to prevent this with firewall. Antivirus is also a good idea. Even if you are on Linux, you want to use antivirus to check for your email attachments before you open them, and files if you got them through the USB or some media that you attach to your PC. And think of the hardware also. What happens to your Android if you lose it? Did you use the full disk encryption for Android? Did you protect your camera on your PC or on your phone? We also distribute that on our CryptoParties, so stickers that they can apply on their devices to hide the camera. For the location, there is not much solution. We had this here in Hack Club. found this interesting project called Kill Your Phone that actually has the instruction how to make Faraday cages from some special cloth and to put then your phone in this pocket, so to say, and then nothing can go in or out of this pocket. Not 3G, not radio waves, not Wi-Fi, nothing. So your location is also protected this way if you carry your digital devices in those pockets, special pockets. And I wanted to share this information also. It is showing that most of the attacks are not coming today and in years 2 years before from the usual suspects, so to say, from web browser and stuff like that. Most of them are now based on the attachments or the documents that you will be in contact with. Someone will try maybe to phish you or try to make you open some Word document that is specially crafted, so the virus then comes out of it like a Trojan horse and inspects your traffic or encrypts your hard drive and then tries to seek some money from you to be decrypted and stuff like that. So it is very important to try to see and inspect the attachments in your email before you open them. If somebody hands you over some USB or some device or send you some link to some documents, make sure you check them first against viruses and stuff like that. There is a cool online website called Virus Total, and you can upload link, you can paste it link, or you can upload some files up to, I think, I don't know, 50 megabytes or something like that. So you can check for viruses on it. And the Virus Total will actually check for, I think, 70 different antivirus engines, so for everything that you send it to. So you send it some link or some file, and it will check against 70 antivirus software. So you will be protected not by one, but by all, almost, antivirus software. And make sure you do it before you open random links or random documents. And for the social networks, this is like the bonus category. I would like to advise everyone to use open source, decentralized social networks where censorship is less likely to happen. And if it happens, you can easily switch to another, because most of this open source decentralized software is distributed and connected to each other. So if you get banned from one, you can easily make account on another and just continue with your philosophy or your points. Main one is alternative for the Twitter. This is called Mastodon, and it allows you to paste up to 500 characters in one message, in one post. So unlike Twitter, that I think allows 100 or something like that, 140, or maybe they doubled it now. But this 400 characters actually means that you can use GPG to send signed or encrypted messages. So it is large enough to employ those software on it. So you cannot use GPG on Twitter because you don't have enough characters to do it, but you can do it on Mastodon. Also, you can find the instance, that's how they call their separate servers, instance of your interest. So if you're into security and privacy, you can easily find instance where the people with similar interest gather around. So you can be in that community, and just in that community, not be bothered by others. And for other, there is a Facebook alternative called Diaspora. Not that developed like this alternative Mastodon for Twitter, but there is. Like, if you really want to go off Facebook, you can there is an alternative, and you can probably manage with Diaspora. I used it for 2 years, not much, but I made a few posts, likes, and stuff like that. I never used Facebook, so I cannot compare it actually to the Facebook, but for me, it was good enough because I just wanted to paste some of my articles and stuff that I wrote, and it was functional. And the Friendica also. Friendica is also another alternative to Facebook, and it is very functional from my perspective or point of view, because it does what I want: to post something and to get notified, to follow users and the content that they post, and that's all there is. So yeah, that will be the end of this presentation, and I'll go back to the start and ask you all if you want to join us or join Hack Club. I hope when this corona ends that we can all gather around here in Hack Club and have some security meetings, or another crypto party. We can check each other keys, sign them, and stuff like that. So anybody has some question, I will try to answer them.
We have gone a little bit over time.
Thank you, Yari.
People are saying something in the chat room. I don't see.
No, for now, no. Okay, I think we got a little bit over time. Maybe people are tired. So if you want to contact us, you can always do there. You can go to cryptoparty.rs, and I think there is email contact@cryptoparty.rs. You can easily find it there. We are also, unfortunately, still on Twitter, but we have a Mastodon instance also, and we are mostly here in Hackerspace. So if you are in Belgrade, you can easily contact us via forum, or you can just come by here.
So thank everyone, and I think we're gonna close the day and see you all tomorrow.
Thank you. Susan says, Swad says thank you.
Swada says thank you. Okay. So you had my mic on, but that wasn't me. Thank you so much, Peter.
No problem.
And we did go a little bit over time, but thank you so much for being with her tonight. We have these masks here in the hackerspace, and there are more people. And hope you have a great evening, and hope to see some of you tomorrow. We have a fantastic workshop on feminist futures and 2 presentations about the internet and COVID time. So thanks everyone very, very much for coming to the Crypto Party, and thanks to Predrag and all the volunteers and everyone who stayed up this late. Thank you. See you again. Bye.